So as a user, what I probably want to do when I'm finished force optimizing a part is generate one of VERICUT's reports that shows a history of what occurred. Now VERICUT's reports are customizable, and this is just one of the templates that comes with the software. So I'll put my name in here and go ahead and save a report. What the report in this case will tell me is what material I was machining. Did I have any errors or warnings in my program? Earlier you heard me say it had already been verified to not have any, so I expected nothing there. A summary of your savings, the files you used, and then here's a summary of the tools that ran and were optimized. Each one's listed by the description in VERICUT's tool library with a picture and where it was loaded on the machine or how it was called at the machine. I've documented what the optimization settings were for each tool, and then it gives me the original runtime, optimized time, and the difference. So 45% savings, 22% savings, 43, 50% savings. You can see that the savings are dramatic in this case. Now here's a tool which actually has a negative number reported, which you might think is odd. Well, what happened in that case is the tool was originally programmed too aggressively for the finishing operation it was scheduled to do. So what force optimization did was notice that the chip thickness was too high, and it adjusted the tool feed rates downward to make it run properly and give the best finish that it could. And that's all of the green area that we see here. That's where that happened. So even though it's reported as a negative savings, it's significant for having the best part finish that's needed. And as a programmer, what's nice for me is I didn't need to keep track of that. Force just took care of that for me and took my roughing feed rate I had in there and fixed it. So that's a great savings for me as a programmer. And down here we have the tool use bar, so you can get that same visual look that we saw here in VERICUT as a reference of how much savings there were. So a nice example of VERICUT reports. We'll look at another report coming out of Tool Manager. If you recall from my earlier comment, each tool has a stock material record used for optimizing this tool and also describing how that tool is supposed to be used. These can be created by the NC programmer, or more frequently they're downloaded with the cutters from places like Machining Cloud, and also tooling databases like Zoller and TDM have the ability to store this information with the tools. We call it tool intelligence. When tools come in with intelligence, you will see these records here, and generally what you would do is just tell VERICUT at that point you want to go ahead and use it for force optimization. So let's take a look at one of these. It has cutting limits, which is the effective usage range for these tools, and VERICUT has the ability to check those against your NC program if you want. You just turn on the ones that you want checked, and then VERICUT has a cutting limits check in the project tree, and we'll check all your tools to make sure you're using them properly. Really helpful when these values come from a manufacturer of the cutting tool, because they know how that tool's supposed to be used, but you can put in the values as well. When it comes to optimizing, optimization must be done within the range of the cutting limits, so you always want to address the cutting limits first, and then here's the switches that you have for what's available for how you optimize the tool. Just air, VERICUT also has an OptiPath product, and then force optimization, which is what we've been doing here. Now down in this group, the optimization settings, this is the key for optimization. So you can read the little comment here and it tells you exactly what to put in. And you can put these numbers in either from the graphs by looking at the graph activity, or if you know them from the cutting tool manufacturer, if they're not already there, you can put them in. This being the roughing cutter, it's listed for almost 4 thousandths for the ideal target chip thickness, and it has the force limit here, which you can see. You also have limits for spindle power or tool deflection if you want to turn them on. And if you don't want to limit them, you could just have VERICUT issue warnings for if you go beyond them. If you look at the same tool used for finishing, you'll notice it has a different value for a target chip thickness. This is because finishing cuts are lighter cuts. It also has a lower value for force, a much lower value. And the limit for tool deflection is turned on. So what this is going to do for me, it's going to create nice light finish cuts held to a constant chip thickness and also prevent overloads of the tool, which could potentially cause deflection. This is going to create better part finishes and more dimensionally accurate machined parts as well. And we can go through each one of these cutters and see that it has different values for what that cutter is intended to do. Now, something else that we can do with the tool manager here is create a report of all these tools that we just ran in the simulation. Taking a look at Excalibur, there's a feature here called Annotate Tool. VERICUT knows the dimensions of all of your cutters, and you can see them right here. This isn't anything I had to set up ahead of time. They're just part of the tool. So I could click through each tool, and you can see that it has different dimensions. Pretty handy to have this information come out in a report. You'll notice this tool is even sectioned. To apply a section to a tool is very easy. You simply go in, add the section, and it can be applied to everything in the tool, or like I did, just the holder component so that I can see the overall length of the cutter. The other thing that I really like about this window is that it gives me the stick out range of the tool from the face of the holder to the tooltip, which this is very significant when it comes to ensuring the shop has the same tool setup that you had in the simulation and the optimization. Remember that VERICUT's calculating deflection, and deflection is influenced by the length of cutter sticking out of the holder. What we'll do is go to Report, create a PDF report, and here we have a nice listing of all the tools that were used, what their gauge lengths and overall lengths and stick out lengths were, and dimensionally what they were. It also includes the description of the cutting tool, as well as the pocket number or however it was loaded on the machine. Great history information to have stored with this job or pass along to the tool crib to make sure that they set up your tools the way they were set up in the simulation. If they are different than you are, then it might be a good thought to go back and resimulate things with their cutters to make sure they're not going to introduce problems with holder rubs, shank rubs, and so on. So I'll close this report and I'll open another report just to show you an example of different kinds of metrics that can be recorded. As I mentioned earlier, VERICUT reports are customizable, so you're able to create the template with the look that you want, incorporate company logos and so on. But here you see all different kinds of machining metrics, material removal rates, averages, depth of cut, width of cut, feed per tooth, all the classical things related to machining. And they've elected to group these things based on operations and the individual cutter paths within those operations. Just another example of using VERICUT reports to get data. So I think that's a pretty good fly-through of what VERICUT Force optimization does, how it does it, and the different features in VERICUT that help you understand the machining process. We then took a look at the VERICUT reports to create historical information for what we did, and hopefully you found all of that information interesting. By optimizing using VERICUT Force, you'll be able to optimize NC programs that you're programming today in your newer CAM systems with the more advanced cutter paths, and also your existing cutter paths that you have laying around the shop. The same software optimizes them both to give you ideal constant chip thickness as much as possible while simultaneously reducing any excessive forces or spindle power or deflection. Thank you for watching, and visit cgtech.com to learn more.